In this example here, the expression that we're asked to factorize has two terms, and each term has both a number and a letter. To factorize this, we can start by rewriting this expression, but instead of writing x squared, actually write out x times x. So 12 times x minus 16 times by x. Now on the next line, we're going to do the same thing that we did before and try to find the highest common factor of 12 and 16. So that's the biggest number that will divide into both 12 and 16. In this case that number is 4, so we're going to write that down. But before we open up the brackets, we're going to take a look at the letters here and the letters here. And we're going to see how many times the same letter appears on both terms. So we have 1x here and 1x on the right hand side as well. And then after that, that's it. We have another x here, but we don't have a second x in the second term to partner it up with. So we're going to write down 1x as well. And now we're going to open up the brackets. Now that we've done that, we're going to take both terms and divide them by 4x. 12 divided by 4 is 3, and x squared divided by x is just 1x. 16 divided by 4, or negative 16 divided by 4 is negative 4, and then x divided by x is just 1, so they essentially just cancel each other out, and we're just left with negative 4 on its own. And so that's it. That expression is this one that we started with, but now fully factorized, put back into brackets. So now let's try to factorize this expression. That's 15x to the power of 5, add 20x cubed. First of all, like before, I'm going to write out the x to the power of 5 and the x cubed in full. So we'll have 15x times x times x times x times x, and then add 20 times x times x times by x. So now on the next line, I'm going to try to find the biggest number that will go into both 15 and 20. In this case that's 5. Next, I'm going to look at all of the x's in this term and in this term here. I'm going to try to pair them all up. So I've got 1x there and 1x there. I've got a second x and then a second x there. A third x and a third x in the second term. But then that's it. I've got two x's left here, but I've got nothing on the right hand side to pair it up with. So that's x times x times x, so that's x cubed. I'm now going to return to the original expression and divide both terms by 5 x cubed. (15) divided by 5, first of all, is 3. And then x to the power of 5 divided by x cubed, well, we subtract the indices, so it's going to be 5 subtract 3. So that's going to be 3x squared. 20 divided by 5 is 4, so that's positive 4. X cubed divided by x cubed is just going to be 1, so we don't need to bother writing that down. And there we go. That expression has now been factorized to become this expression. Here we have one last example. 3p squared q minus 5p. I'm going to start as before by writing out the p squared in full. So 3 times p times q, subtract 5p. Okay. Do 3 and 5 have any common factors? No, they don't. They're both prime numbers, so they're not going to. Okay, let's look at the p's. I've got a p in the first term and a p in the second term. There's another p here, but I've run out of p's on this side. And then if I look at the q's, I have a q in the first term, but none in the second term. So the only thing that's common to both terms is 1p. If I then divide both the original terms by p, p squared divided by p is going to become just 1p. So I end up with 3pq. And then p divided by p over here, these are going to cancel out, leaving me with just -5.